I'm going to open the method one first and start at the top, step number 1. Step number 1 is change to improper fractions. Change to improper fractions. Step number 2, find the LCD. Who remembers what LCD stands for? If you didn't know that, then write out the words lowest common denominator. Step number 3, change the numerators, which I'll explain more in a second. I ran out of room, so I just abbreviated. If you're not an abbreviator, then write out the full word, whatever works for you. Change the numerators. Combine the numerators. Combine the numerators. Step number 5, change to mixed fraction. Change to mixed fraction. Step number 6, reduce if necessary. Reduce if necessary. Am I going too fast, or is it okay? You would answer to one of those possibilities. Too fast? Okay. Awesome. I'm just going to close this for a second so we can write down the example. That's why I wanted you to glue it to one side, because I wanted to have room to do the example. We're going to take 2 1/4 and add 1 2/3. 2 1/4 plus 1 2/3. Okay, let's open it up and do that on the example side. You guys okay? Up in the bucket.
I am.
It's there. So I'm going to number the steps so that it's going to correspond to the other side. So when you're like, what's step 1? Now you'll know that's changed to improper fractions. We did this last week. Who can remember? How do we change a mixed to an improper? Yes? And then? High five to you. Multiply by the bottom, add the top. So 4 times 2 plus 1. 3 times 1 plus 2. Step number 2 is finding the lowest common denominator. What's the lowest thing that you can divide by 4 and divide by 3? So we're going to put it over 12. Step number 3 is going to be to fill in the tops. So fill in the new numerators. How do I multiply, or what do I multiply 4 by to get 12? So this whole fraction is being multiplied by 3. And so 9 times 3 would be? Awesome. What do I multiply 3 by to get 12? So that whole fraction is being multiplied by 4, so 5 times 4. That's what I mean by change the numerators. So multiply by whatever you need to. Step number 4 is we put it over one denominator, and we're just going to combine the numerators. So I'm going to do this in 2 steps. The first one, I'm just showing you what we're doing. We're going to add them in a second. You don't need to write that step. I'm just showing you when you look back what's going on. If you can jump right to the addition, that's fine. So what's 27 plus 20? Okay, so if you can jump right to 47 over 12, nothing wrong with that. 5, we're going to go back to a mixed fraction. So how many times can we divide 12 into 47? 3 times. We're going to have 3 wholes. What is 3 times 12? 36. So how much do we have left over? Can we reduce? So this would be step 6 if we had to, but we don't have to in this question. Does that look familiar from last year? No, not at all? Like any of the steps? Scares me a little bit. Top a little bit, okay. Any questions with the steps then if it's new to you? Sorry, say that again. Yeah, right here. That's finding the tops? You're probably right brain, because right brains read down, and then we're like, 1, 2, 4, what's going on? Just tucked over here. It's a right brain thing to put it off to the side. Close this. Again, the reason we're doing this is it's tactile, it's visual, it's also right-brained. I put the example here so that when you're studying with your notes, you don't have the work right in front of you, so you're not going to cheat yourself. You can actually do this on a piece of paper and then check the answer, and it's not like right in your face. Here's what we're going to do, 6 examples today. We're going to do a little integer refresher. What happens when you multiply negative times negative, negative times positive, positive times positive, negative times negative. I'm going to show you a left brain way to remember and a right brain way to remember, and you get to pick any way you want. I don't care. Questions so far? What happens when you multiply a positive number by a positive number? So positive 3 times positive 4. It's positive. And what happens when you multiply a negative by a positive? So negative 3 times positive 4, negative. And what happens when it's reversed, when you have a positive times a negative? And that's a negative. And the last one, negative times negative equals positive. Why? Why do we have that little negative times negative equals positive thing? I know, I always love asking this because you learned it in grade 7, you reviewed it in grade 8, and then you're like, I don't know, somebody told me that. Why? Why does a negative times a negative equal a positive? You'd think tactile, you're actually moving it. No, nothing to do with that. Well, think back to English class for a second. You know when the teacher is like going over grammar and they're like, don't use double negatives. What's a double negative in English? Double negative. You never heard double negatives in English? Okay, let me tell you a double negative sentence, and you're going to see this is going to sound really weird when you hear it. This is a double negative sentence. I don't eat no bananas. Like already you're like, that doesn't sound right because we don't say that in English. It's a double negative because I have the don't, which is do not, and I have no. I don't eat no bananas. What does it actually mean in English if I say I don't eat no bananas? Means I do eat bananas, because a negative times a negative, double negative equals a positive, that's why. Yep. So if I say don't do no homework, I'm telling you to do your homework. Just we wouldn't say that because that sounds weird. A right brain way to do the same thing if you have the same signs. So either plus plus or minus minus. It's going to be positive. If you have opposite signs, so either a plus minus or a minus plus, negative. There's left brain, there's right brain. Pick whatever one you want. Method 2. One of my international students showed me this last year. He was Brazilian, and this is the way they do it. And I was just like, oh my God, I've never seen that, and I would never think of that. So I just love showing you different ways. If you like one of these ways better, great. I just like to give you opportunities. I'm going to draw a tic-tac-toe board, so like the 9 squares, the 2 intersecting lines. You've played tic-tac-toe before? And instead of putting X's and O's, I'm going to put positives and negatives. So I'm going to go down the main diagonal as positives. So we call it the main diagonal. The top left to the bottom right is all positive. Everything else I'm going to put negative. Still with me so far? Every column, every row, and every diagonal will give you all the rules with the negatives and positives. So let's look at the row. A positive times a negative is? Negative times a positive is? A negative times a negative is? Let's do the columns. Positive times negative? Negative times positive? Negative times negative? Let's do the diagonals. Positive times positive? Positive times negative? I know, I've never seen that in my 41 years of living on this earth. What is that? How cool is that? Explain. I have never heard of a dumb sleeping owl trick. What? I'm intrigued. Do you still have your notes from last year? No. Oh, I'd love to see that. What school was it? Hedges. I was a Hedges grad. Nice. No, I've never seen that before. So just make a note, all rows, columns, diagonals, state the rules. Again, if you're like, nope, don't like that, then use one of the other methods. I just always like to give you choice because it's going to click for some kind of brain. And again, I love to learn new ways because that never occurred to me. And I'm like, oh, that's the way they do it in Brazil. How exciting is that? Do you have your piece of paper? Do you have the title written down? So flip to the thing. And I always put it up here too. Again, you have done this before. All we're throwing in now is the stuff with the integers, the stuff with mixed numbers, the stuff with improper fractions. We're just making it a little bit more difficult from the questions you did last year. We're not adding anything new mathematically. So I'm actually going to throw in a different step than what we just talked about because now we have to take care of the integer work. So that's the first thing we're going to do is just take care of this integer. When I have a negative followed by a negative, what does it become? Positive. So I'm just going to rewrite the question with a positive. Okay, so we take care of integers first. Oh, that sounds so bad. Have you seen a doctor? That's not good. So 6 steps, we just wrote them down. We just did an example. I'm not going to change them. It's the same 6 steps. Step number 1, change to improper. Done, right? We don't have to because these aren't mixed fractions. Step number 2, common denominator, 5 and 10. Oh, I don't want orange. Step number 3 is change the numerators. So how do we go from 5 to 10 in the first fraction? So 2 times 2 on the top is? If you're visual and you like to write that arrow and then the times 2, then do it. If your brain doesn't need that, then don't do it. How do we go from 10 to 10 on the other fraction? It's times by 1, so a 1 times 1 on the top. Step number 4 is just combining the numerator, so 4 plus 1. Step number 5, change into improper if we need to, or sorry, into mixed number if we need to. Nope. And step number 6, reduce it. What's 5 divided by 10? There we go. Let's look at B. 1/9 plus negative 2/3. 1/9 plus negative 2/3. Am I going too fast? Integer work first. A positive times a negative. So opposite signs means it turns negative. Step number 1, change to improper fraction. Don't need to. Step number 2, common denominator. Step number 3, change the numerators. How did I go from 9 to 9 in the first fraction? So 1 times 1. And again, if your brain likes that little arrow with the times 1, put the times 1. How did I go to 3 times 9 in the second fraction? So 2 times 3. Step number 4, combine the numerators. So I'm keeping the bottom and I'm just doing 1 minus 6. Negative 5. Change to mixed. Reduce. End a question. You notice I did the work differently. This one I did it vertically, this one I did horizontally. I don't care. Pick and choose whichever one you like better. If you're going to do horizontally, please don't squish your fractions onto one line. Like some people will do this, and then it's so small and it's so squishy, and then sometimes it gets sloppy. I just can't see it. So at least use 2 lines for your fractions, just because I'm old and I have bad eyes and it's easier for me to see. But I don't care if you work down, I don't care if you work across. This tends to be more left brain, this tends to be more right brain. Don't care. Questions so far? Okay, let's make the numbers a little bit bigger now. So 3 2/3 plus negative 1 3/4. So you notice number 1 we had brackets, number 2 we did not, now I'm back to brackets. Did it matter? Not at all. It doesn't matter if you have the brackets or you don't, it's still combining the 2 signs in the middle. What's a plus and a minus? Minus. And sometimes I just write it on top rather than rewriting the question because I get a little bit lazy at the beginning. Step number 1, change to improper. So 3 times 3 plus 2. 4 times 1 plus 3. Step number 2, common denominator. What's common between 3 and 4? How did I go from 3 to 12? Times by 4, so I have to times the top by 4, 11 times 4. And again, if you didn't know that right away, that's why we're going to do Flashcard Friday every Friday to bring up those base skills. How did I go from 4 to 3? Oh, I just told you. How did I go from 4 to 12? Times by 3, 7 times 3. Step number 4, keep the denominator. Add the top together or subtract the top or combine the top. 44 minus 21. Now some brains like to do subtraction vertically. So if this is the way your brain likes to see it, then do it that way. There's nothing wrong with that. If you need to stack it, stack it. What's 4 minus 1? And then what's 4 minus 2? Step number 5, change to mixed fraction. How many times does 12 go into 30 or 23? What's the leftover? Step number 6, reduce. Can't. Final answer. If you would rather do this question vertically, then do it vertically. If you don't want to draw these arrows, then don't draw the arrows. If you don't need to do this, then don't do it. It's completely up to you. How many math teachers say, do it any way you want? Usually we're like, do it my way. Questions so far? Show me a thumb. Getting this? Kind of getting this, not getting this. Awesome. Just looking for a thumb in the back corner, Brandon. Awesome. Negative 2 plus 1 9/10. Negative 2 plus 1 9/10. First thing, check in the middle. Do I have 2 signs? So I don't need to do that step that we did with orange, or I did in orange all the way along. I'm just going to step number 1. Step number 1 is change to improper fraction. Go ahead and do that. Two times 2 plus 1. So that negative is just going to hang out in front. I just copied him down. I'm not really concerned about him. He's just hanging out there. It's all fine. 10 times 1 plus 9. Who had those two improper fractions correct? Awesome. Step number 2, write down the common denominators. Write down. Give everyone a chance. Common denominator between 2 and 10. Write down the new numerators. That's hard to say, new numerators. How do we go from 2 to 10? What did we multiply by? 5, so 5 times 5. And again, that negative just carries along. I'm not concerned about him. He's just in the front there. How do we go from 10 to 10? Times 1, so 19 times 1. Keep the denominator, add the numerators. Negative 25 plus 19. You can do that vertically. You can do that with a number line. You can do it with a thermometer. Whatever makes sense to you to add those integers, do it that way. Step number 5, change to mixed. Don't need to. Last step is reduce it. So write down the reduced fraction. The reduced fraction is? Do you notice the first 3 examples I did with you? This one I let you do it, and then I did it right after you. So that's how I tend to do examples. The first couple I do with you, then you do a step, I do a step. Now you're going to do with a partner. I'll give you a couple minutes, and then we'll do together. So just turn and talk to someone, 2 minutes-ish. Do letter D, E, sorry, together. Number 1, change to improper fraction. What does the first fraction become? Confirm 7 over 3. What does the second fraction become? Agree on 5 halves. Step number 2, common denominator, common between 3 and 2. Step number 3, change the numerators. How do we go from 3 to 6? 7 times 2. How do we go from 2 to 6? 5 times 3. Step 4 is keep the denominator, add the numerators, 14 plus 15. Step number 5, change to mixed fraction. How many times does 6 go into 29? What's the leftover? The last step, step number 6, reduce. Final answer, 4 and 5, 6. Who had that? High five someone with their hand up right now. Like I want to hear it, like a big loud high five. Awesome. If you didn't, who cares? We're just practicing. So you fix it and you go on. Okay, the last example, no partner this time. Try it on your own, all by yourself, and then I'll do it with you in a couple minutes. What? Step number 1, change to improper. Here you go. So you'll notice sometimes I go through it with you, sometimes I'll pre-write it so that you need to figure out what I did because that's a learning strategy. Step number 2 and 3 is common denominator and get the new numerators, so over 12. So it'll be 9 on 12, 20 on 12, and 6 on 12. Step number 4, keep the denominator, just smush the top together. So I just did 9 plus 20 minus 6. So if there's 3 numbers, just combine them all together. Step number 5, change back into mixed fraction, which would be 1 and 11 on 12. And step number 6, reduce. Can't do it. There's a final answer. Put your hand up if you had that as a final answer. High five someone with their hand up.